Hi everyone, and welcome to our video on solving trigonometric equations that have a trig function that is squared, but only a single trig function that is squared. So here we have secant squared of x and then a constant. And then the other one is sine squared of something and then a constant. All right, well, let me scroll. These ones we'll treat differently. So notice I have a squared trig function and another non-squared trig function. These would be factoring problems. Okay, so we'll see those in a second. So if it's just a single squared trig function, no other trig functions, then we often will just do a square root to continue solving these. Okay, so what we want is first to get the trig function by itself. So I want this all by itself, which really is nice in this problem. I would just need to add 4. Okay, and then we would have secant squared of x is 4. Now that I've got secant squared of x by itself, I want to get rid of the square, so that means I should square root. Now, it's important that we make sure we have plus minus involved on our answer. So this is telling us now secant of x would be plus or minus. Square root of 4 is 2. Now, I don't like secant anymore, so I kept it at the beginning, but now that I have secant all by itself equal to a number, I would say let's do our reciprocal property and change it to cosine of x and then flip the answer over there. So still plus and minus out in front, but 2 gets flipped to be 1/2. Okay, so now that we've got cosine of x equaling plus or minus 1/2, I usually just keep it like that. And then now I'm back to my unit circle and saying, well, I need the x coordinates where I have a positive or a negative 1/2. Well, where I have a positive 1/2 is right there at pi thirds. And then I'll also oops, not right there. We'll come back to that in a second though. The other positive 1/2, and I can mark it. Okay, so sorry, it's a little small. There we go, 1/2 and radical 3 over 2. And then 1/2 and negative radical 3 over 2. So the x coordinate of positive 1/2 are right there at pi thirds and right here at 5 pi thirds. And then the one with the negative, let me go ahead and color code it in purple, where I would have a negative 1/2 as an x coordinate would be at 2 pi thirds and 4 pi thirds. Okay, so that's where I would have the negative 1/2 as the x coordinate. Okay, and that one, might as well. Okay, so the negative 1/2 and negative radical 3 over 2 is down there. But I like to plot it on a single circle, and I mean, the color coding's not necessary, and we don't need to break it down as far as I did. But at this point, we could still see, well, if I have the plus minus, it looks like I could have just taken all of the answers that would have had 3 in the denominator on our unit circle between 0 and 2 pi. Okay, so our x would be pi thirds, comma 2 pi thirds, comma 4 pi thirds, and comma 5 pi thirds. Now this is the answer on 0 to 2 pi. They didn't ask for that. They did say solve, which means it's all solutions. So now we're going to take those 4 answers and add 2 pi k to them. Okay, so pi thirds plus 2 pi k, 2 pi thirds plus 2 pi k, 4 pi thirds plus 2 pi k, and 5 pi thirds plus 2 pi k. Okay, and then that I would say is the official answer. Yeah, it gets a little tedious writing those out. We could have, now I usually don't want to maybe even mention this, but I will. We could have said, oh, pi thirds and 4 pi thirds are pi apart. So that means I could have condensed that answer. Same deal with 2 pi thirds and 5 pi thirds. Those are pi apart. So I could have condensed this answer to make it a little shorter. But I think it's better to go slow and steady and do longer answers so you don't have to worry about thinking about little things like that. You just get the answers and just do plus 2 pi k and then you're done and you move on. Okay, let's do one more where I have a sine function. So it doesn't matter what the trig function is, but this side is the sine function. And what we'll do is, same deal, I want to isolate the trig function, get it all by itself. So that means our first step would be to add 2. So we would have 5 sine squared of t is equal to 2. Again, I'm still trying to get that trig function by itself, so we should divide by 5. And we would have sine squared of t equals 2/5. And then now that I've got my trig function that's squared all by itself, we can square root both sides. Just don't forget plus and minus. All right, so now I've got sine of t is equal to plus or minus the square root of 2 over 5. Now, we might need to rationalize this, but we're going to need a calculator on this problem anyway, okay, because this is not going to be a number that's on the quoted unit circle. So not on quoted. And again, what I mean by that is like the previous problems, like cosine of x equaling plus and minus 1/2. We know that's on the unit circle that they like us to use to find exact values. But this one is not. However, it's still on the unit circle, not on quoted, unit circle. However, it still is. Now again, these are y coordinates. Plus and minus radical 2 over 5 is a y coordinate. Okay, so I don't know exactly where that is in here. I'm just gonna start labeling and say, well, I think maybe it's about here. So this is a positive y coordinate that has radical 2 over 5 in it. And there should be one right here as well. There's another positive. And then there should be the negatives in the lower quadrants. Okay, so we've got these and these right there. All right, and so to get these answers is where we would need to introduce our inverse trig. So we would need to do our sine inverse of both sides. Now, when we do the sine inverse of both sides, we should probably separate the plus and minus into separates. So we would have t is equal to sine inverse of the positive radical 2 over 5. And we should have the, let's see, let's do it in purple, the sine inverse of negative radical 2 over 5. Okay, so those are going to give us two answers. So the positive answer, remember our inverse trig properties, our positive one that I'm leaving in blue should be in quadrant 1. The negative answer, when we plug that into the calculator, would be in quadrant 4, like that. Okay, and then we'd had a separate video where we dealt with the calculator. So remember, once we get an answer, we just take that answer and do pi minus the answer to get the others. Okay, so once we have those, we would have our other two as well. Okay, so if these get plugged into the calculator, okay, so I would have t is equal to, now I'm not sure if I can pull this up on my screen with the calculator. I'm not sure if you see this. So I am going to just type it in real quick on a calculator that I'm probably not showing on the screen. I think that's how this recorder works. But we did it in a previous video, so I believe you could type in an answer in a calculator. Just make sure it's in radians. Okay, so when we do type in the first one, we will get 0.68 in radians. Okay, so this in the blue, let me mark it in blue. Okay, so I entered this in a calculator and it gave me 0.68 radians. And then I know instantly again, comma, based on the previous video with using a calculator, I should take that answer and do pi minus it to get the second answer right away. Okay, so let's go. Again, I'm just going to enter that real quick on the side. And we'll write it down afterwards. Okay, so pi minus 0.68 is 2.46. Okay, and that would be this one in the second quadrant. Okay, so there's two of our answers. And now in the purple, I'm going to enter this on the calculator. Okay, so if we enter that in the calculator, again, sorry if you do want to see it. Sorry, but I think you could enter these. Okay, so this gives us negative 0.68 in the calculator. Oops. Okay, so we've got negative 0.68. And again, I'm going to use the rule and say, well, I should do pi minus that answer. So it is pi minus a negative, which really would be now pi plus to get the second answer. Okay, so we've got pi plus 0.68. And that gives us 3.82. Which would be that one. Okay, so there's 4 of our answers as decimals. And so to finalize it, for all solutions, we are just going to say, well, take those 4 answers and do plus 2 pi k to them. Okay, so I'm going to put that right here, comma. Okay, so 0.68 plus 2 pi k, 2.46 plus 2 pi k, negative 0.68 plus 2 pi k, and then 3.82 plus 2 pi k. So I don't have them in order, that's fine. But that is all solutions. Okay, so they didn't tell us that we were going to use a calculator on this problem, but if you get a value for a trig function that is something that's not on the quoted unit circle, then that's when we would need to use it. Now, in the homework, they're usually going to let you know if you have to use a calculator or not, because the way that they word it, remember, these are exact values, like in the first problem, because we didn't need a calculator. These, they would say, round to a nearest place value. These are approximations. Okay, so anyway, so this one, they don't make us use a calculator too often, but it's good to know how to use it still for when we do need it. Okay, so that's if there is a single squared trig function. That's how we break these ones down. Okay, so thanks for watching. If you have questions, please let me know. Otherwise, see you again soon.